Hello everyone. Today we are going to discuss the problem sorted and rotated minimum. So it is a difficulty easy question. So coming to the question, a sorted array of distinct elements ARR is rotated at some unknown point. So our task is to find the minimum element in it. So it seems to be a very easy question, but there is a twist. So if you see the first example, ARR 5, 6, 1, 2, 3, 4. So if you see, it is a sorted array actually. Means if we keep the 5, 6 at the last, 1, 2, 3, 4, 5, 6. But it is rotated by two positions. So the 5 and 6 came to the front. So instead of 1, 2, 3, 4, 5, 6, it is 5, 6, 1, 2, 3, 4. Like that. So in the second example also, it is 3, 1, 2. Actually it is 1, 2, 3. So if it is in the first example, we can easily say that the minimum element is 1. So the minimum element is 1, so the output is 1. So I have to just print the minimum element from the given array as the output. Assumes to be a simple question. So let's see. So in the second example also, the numbers are actually 1, 2, 3. So they are given as 3, 1, 2. So if you see, the output is again 1. So in the third example also, 4, 2, 3. Actually it is 2, 3, 4. So rotated by one position. So like it is shifting to the right by one element. So the twist is, the expected complexities are time is big of log n. So it is not n. So we need to use the binary search kind of thing because it is sorted, but due to its rotated feature we are going to modify slightly in this code. So space is also big of 1. So this is what the twist or the actual hurdle we have to pass. So the time should be big log n, big of log n. So we can say it is asked in many companies, the big companies, Amazon, Microsoft, Samsung, Adobe, Morgan Stanley, etc. So we can see it is related to searching. So now if we discuss the approach, so let us write some of the rules. So actually what we know about the binary search. So there are two pointers low lie at ends of the array. So next they will keep on moving based on some conditions in the loop until low is less than high. It will continue. If so these are the four simple things we know about the array. Forgot. So these are the conditions we actually know before also. So what is a normal binary search? Excluding this rotated feature, normally on a sorted array. So there are two pointers, low and high, at the both ends of the array. Let us write the ends of array. So we compute the index, mid index, and use the some conditions. So the low and high, they both will keep on moving based on some conditions. So until low is less than high, the process will continue, and at the last, when the loop terminates or the less is greater than high or equal to high, then the result is computed. So this is what actually the normal binary search does. So in our code, the conditions used are slightly modified because of the rotated nature of the given array in this question. So the first one is, so the first two steps same. So the first two steps from the normal binary search is same. So after that there is a condition which is, if the mid value is greater than high value. Generally in a sorted array, the mid value is always less than high value, means the end value, because it is sorted in the ascending order. But if it is the mid value is greater than high value, then we can see in the first example, later we will discuss the example. See, we can see the mid value is greater than the high value. So like these cases. Then right of array is so if you see in this particular program, the approach is, so the first two steps are same, which are, we use the 2 pointers low and high at the ends of the array, which is low is equals to 0 and the high is equals to, the last index of the array. So the second step is also same, which is we compute the mid index and use some conditions. So what are the conditions? Those are going to be changed in this question. So if you see, there are only two conditions which are if and else. So the first condition is, if our mid value is already greater than the high value, then that indicates that the right half of the array, starting from the mid value to the high value, will only contain the minimum possible value. So that is a condition. So if the second condition means, if it is not in the right half, then it obviously be in the left half. So these are the two checking conditions iteratively we use to find the minimum value. So at last, low and high both will be equal, the same value. So either low or high will be the minimum value. You can return any one of the as a result. So we say dry run. Dry run means, the example we will be taking means, let us take the simple example 3 1 2, 3 comma 1 comma 2. So there are only 3 elements, so it will be faster. So now the first step is low equals to 0, high is equals to 2. So is it 0 1 2? So yes, high is equals to 2. Now the second step is compute the mid value. So mid is equals to 0 plus 2 by 2, which is mid is equals to 1. So now if we check with the conditions, we set the condition means, if the mid value, which is a 1 value, is if greater than the high value, which is 2, which you can see it is not. So later, if we can see the else part, then what it is, it will be in the left half of the array to be searched. So what to do? Left half we can go by adjusting the high value. So high is equals to the mid value. So now low is equals to 0 and high is equals to 1. So they are the updated values. Now again compute the mid value, which is 0 plus 1 by 2, which is 0.5, which is again 0. So if you see the termination condition, low is less than high, so the condition is true, means 0 is less than 1. So again one iteration the loop will continue. So mid is equals to 0. So now what are the conditions if the mid value, which is value 3, is greater than the what is the high value? High value means 1. So it is obviously greater than. So we consider the right of. So how can we go to the right of? By adjusting the left value. So left is equals to mid plus 1. Left is equals to mid plus 1, which is equals to mid value is 0. So plus 1 is equals to 1. So now the updated values are L is equals to 1 and H is equals to 1. So if you see the termination condition, left is equals to high. So the loop therefore the output is either the value at index low or index high. So what is the low and high are equals to 1. So the value at index 1 is what? It is 1. So 1 is the minimum element. So in this way we follow this simple 1, 2, 3, 4, 5 approx 5 steps, which are the declaration of low and high, and the second step we will inside the loop we compute the mid value and check using the two conditions, which is to continue the search in the right half of the array or the left half of the array. So due to this binary search kind of thing, the search time will be reduced to log-in, which is the optimized one. So after the termination of the loop, the low and high value will be the same, equal to values. So any one of them will be the minimum value, which is the one in this case. So this is how our logic which we are going to write will actually work in the background, like we can say it as a BTS, which is behind the scenes. So behind the scenes, this is how it works. So this is our whole approach. So let us follow the same steps in the actual code. So what is the first step? It is declaration of the two pointers. So int low is equals to 0, comma high is equals to last index is length minus 1. So dot length minus 1. So now we compute the mid index and some conditions. So they are usually done in the while loop, which we know, the binary search logic. So while our low value is continuously less than the high value, we keep on using the conditions and computing the mid value and adjusting the low and high value. So for that, what is the second step? We will compute the mid index. So int mid is equals to, there is a special formula which is low plus high minus low by 2. So this is what the condition is. So now what is the first condition? If our mid value is greater than the high value. So we also check how it is working here. So if you see in this case, let us say that is the mid value. So mid value is greater than high value. Then in this case, where is our minimum possible value? Is it in the mid values left half of the array or the right half? We can say the mid value or the minimum value is in the right half of the array. So this is logically this our conditions are working. So if the mid value is greater than the high value, then right half is searched further. So the background how it is working. So same, if our mid value, not the index, we should remember index are always sorted nature. So we need to consider the values. So if our mid value is greater than high value, so in this case we need to search the right half. So we need to move the left position indicator, which is L is equals to mid plus 1. Mid plus 1. So if it is not in the right of the minimum value, then it is in the left of. Left of can be searched using the right pointer, the high pointer modification. So we are including the mid value. So if in case is it there or not there, so such that. So we wrote at the last step, which is the result is the minimum value either in the low or high. So simply return any one of them. So which one do we write? Let us write low. Anything we can write, because the low and high value at last will be the same value or the same index. So returning low or high will yield us the same output. So you can see the test cases are passed, sample and the hidden test cases. Now if we analyze the complexity, we used some variables which are big O of 1 and a loop which we need to discuss specifically. So I will explain why. Let us first compute the values. So we know a binary search logic loop will always take a log n time. So the loop time is log n, and the variables are static or take less space or constant space, big O of 1. So finally our code time complexity is big O of log n and space is big O of 1. If you see if they are matching from the given expected ones, so we can see they are matching. So this is the best possible solution to this program using this approach. So go through how the actual conditions on the loop are working in this dry run using this 312, the second sample test case example. So this is what the actual binary search, and what are the few changes in our special approach for this question. So you can compare, because you actually know this logic, so you can compare and just modify your logic to this particular question. So it is going to be easy like that. So see the dry run how it is working, and then go to this simple code. Now if you go why the loop has a log n space, so continuous breaking the so if a loop or a program has continuous breaking of the search interval or the searching interval into the halves continuously until the result is found, then the time shrinks to log n instead of n. So this is what the reason we actually got the time as log n. So you can see the mathematical derivation of the log n in the YouTube. So you actually know. Let's not waste your time. So focus on the logic. So we can say go through this approach, what is the modified from the binary search, and how the dry run of the code is working. So this is how we need to solve this program. The problem link is given in the description. Kindly go and practice the problem. Thank you for watching. Subscribe our channel.